Like every other programming languages, they have their own syntax and roadmap to mastering how it works. Don't forget, programming language is just a tool to achieve what we are trying to build. The end point, the end product is an application that performs a task. How do we get the application? We have to write the code. And we can actually use several languages to write codes that can still do the same thing. We can use Java to build the same thing a C# can build, Node.js and all that. But in this video, we are focusing on the roadmap to C#. What you need to understand on how C# works from basic levels to intermediate and then advanced level. So we'll be looking into all these tutorials here now. While I pull that up, I'll be right back. Welcome back. Like I said, C# is just a programming language. It's just a tool that we use to write applications. Now, when we're writing application, that's a whole different ballgame entirely. Understanding the language is one different thing. Using the language to write an application is a whole different thing. So we write application using the help of framework. And in this video, I'll be talking about the roadmap to dotNet framework as well after the C# aspect. So let's see how this works. The syntax is the most important thing I will advise as the basic requirement. You want to understand how the syntax of C# works, especially if you are coming from a different programming background. The way you write JavaScript or the way you write Java or the way you write any other language, it's not the way you write C#. Different languages have their own syntax. I mean, you can use different languages to build same application, but you can't write them the same way. So understanding the syntax of C# is very important, basic, especially when you're coming from maybe like JavaScript or Java or any other programming language. You know what you're trying to achieve, but how do you write it in C# by understanding the C# syntax? That's a basic requirement. And moving forward to the data types in C# are actually the types that we use to handle the data we are working with. So if we are trying to assign a text variable or a number variable, we use different data types. So for text, we can use string. For data, we can use, for numbers, we can use integers. For decimal number, we can use decimal. We have double, we have float, even date and time. And as you advance, you can even use class as a data type. Now, moving forward to the method. The method is basically a function that we write and then we call it to execute. So you can embed a set of code inside the method, and then you can reuse the code in any other place in the application by just calling the method. Arrays and lists are very important aspects as well. So you want to understand how arrays and lists works, which is you have a set of elements in arrays or in lists, and you want to loop them and get data from those arrays and lists. That's a very important topic to understand from the basic of C# as well, which takes us to the loops aspect. Loops is how you get elements in arrays or lists, and then you call the data out by looping through. There are several ways you can loop. You can use the for each, you can use for loop, for each, and different ways you can loop actually. So that's a very important topic you want to look at in the basic of C# as well. Then conditional statement is very important as well, which is the if else, do while. So that is how you can actually command the code to execute a specific task if the task meet a particular condition. So you can set the conditions in there. So if the age is less than 18, allowed to register. Else, if it's not less than 18, you write out a specific message. And while you are working on that also, exception handling is a very important aspect that you want to take along while learning the C# at this basic level. So exception handling is basically how you handle error in your application, because when your code crash in real life, no user will want to use your application again. So instead of your code crashing, you want to point out a message of what is happening, why the code can execute. That's where you handle the exception handling. And moving to the advanced part, you have the classes and objects. You want to start writing classes and objects. And then you have to learn to debug. This is very important. You don't want to miss this aspect. Learn to debug is actually how you be in charge of your own code. You know what is happening behind the code. You understand. It even makes you understand how code works some more. And using interface is actually an advanced level in C#. I would term that as intermediate, but it's very important. You have to understand how to use interface, which is basically creating a blueprint for your application entirely. So you can use classes to inherit from that interface or implement the predefined method in the interface as well. Abstraction is very important. Abstraction is actually how you protect data in your applications. So when you get to a point where you are writing secured application and you don't want users to have direct call to the back end, so you want to put an abstract layer in the middle of that. So it's just like writing an abstract class. You cannot, instantiate an abstract class. You can only call it using another class, right? So that's like the middle layer to the data, warehouse. So abstraction is very important. You want to understand how abstraction works. And also inheritance is a very important aspect of advanced C# as well. You want to know how inheritance works, which is like a parent-child relationship in classes. So that's very important. You want to know how that works. And then when you're using multiple inheritance, that's when you actually get to use interface, which I've discussed here. Polymorphism is also another important aspect of understanding how the logic works in programming language in general, but I'm using C# as an example in this video. So polymorphism, having same object but different forms, like if you have an object of person, but person or students, they have different languages, different nationalities. So how do you work this out in C#? That's where the idea of polymorphism works, where an object has different forms. Object of person can speak different language. You can have Chinese, you can have Indian, you can have Japanese. Polymorphism will take care of that. Multi-threading is a very important aspect of C# as well, which is understanding how to write codes that are thread safe. I mean, in modern application, you probably don't need this part because we have inbuilt libraries that are taking care of thread safe application, but it's still good to have the basic of how multi-threading works. And encapsulation is protection of data in your applications using dependency injection. You can encapsulate a data in a constructor by injecting it there. So the user can only supply data to the constructor when they are calling it, or the programmer can, actually supply the data when they are consuming the encapsulation and dependency injection constructor as well. So it's a very interesting aspect of C# to understand, or programming in general. So generics, concepts, and collection is quite very important in C# as well. So you want to understand how the generic concept works and the collection entirely. So that's a very important topic. And the good thing is I have actually covered all these topics in my video. If you look at my past videos, I've covered all these topics there, from classes, objects, abstraction, interface, inheritance, polymorphism, multi-threading, and all that. I have them, including dictionary. Dictionary is a key value pair of collection. So you want to use key to pull out a value in a dictionary or in a memory as well. So I've covered that in my tutorial as well. And delegate an anonymous method, I've covered that as well. So you want to delegate a specific function to a service, right? So a whole method will be embedded in a parameter. That's how delegate works, an anonymous method. I've covered that in this channel as well. And then extension method is something I've covered as well. Extension method, like I said here in the abstract class abstraction, there are some classes that you don't have access to as a programmer, right? But you need to use or edit a method in those class. How do you do that? That's where extension method comes in. I've covered that in this channel as well. And then lambda expression, I call that a shorthand method. It's just a simple way of writing method when you are on the advanced aspect, actually. So that's something you want to look into in modern programming, especially in C#. Asynchronous programming is when you have a lot of methods running. For the most part, by default, the methods are arranged synchronously, which means one will execute first. Once that one is done executing, it will move to the second one and to the third one. But in real life, this will for the most part slow down your applications. So you want to understand how asynchronous programming works. In C#, you can use the async and await keyword, meaning whichever block of code has done executing first should proceed. It shouldn't stop one from moving to the next stage. So if method 1 and method 2 and method 3 are running together, and if method 3 finish first, then just execute what is there while we are waiting for method 1 and 2. So asynchronous programming is very important. I've actually covered that in my channel as well, so you want to look into how that works. Now, if you can understand all these topics here, if you can understand everything I've put here, starting from the basic, you don't have to rush. You have to start from the basic. For a basic start, don't even worry about what we have, what we have in the advanced. Just start from the basic, and if you can understand how the basic works, which is this part here: syntax, data type, method, array list, loops, conditional statement, focus on that. There are many tutorials on YouTube. I have some on my channel. The moment you master all of this, take it one at a time. The moment you master it, then you can move to the next stage, understanding how exception handling works, and then you can move to the advanced stage and taking it one by one. Class, debug, interface, abstraction, all these topics here. I've covered them in my channel. And the moment you are actually comfortable with all of this here, then you are really good to go and start programming in C# using the dotNet framework. And that's it for the C# aspect. I mean, there's a lot to C#. C# is pretty deep. I haven't even started talking about the data structure and algorithm, but just to make it easy and round it all up, brief it and summarize it. If you're comfortable with all of these topics that I've mentioned here, then you are pretty much good to go. Every other thing you will learn on the go. You will learn it on the fly, but you need to have this basic understanding. And then the more you start writing in .NET framework, or the more you start building projects, you'll be exposed to a whole other new world of what you can do with C#. You can even build mobile applications, desktop applications, web applications, different kind of front end. We haven't even talked about Blazor. Let's look into .NET framework and go through the roadmap to see how that works. Just something that we can briefly go through that can give you the bigger picture of what to focus on. So if you look at the roadmap that I have here, let's start from the .NET framework itself, which is the hood and the foundation where everything sits on. So that is the framework that provides all the inbuilt library in .NET technology. Windows Form is specifically a graphical user interface that is used to build desktop application. Although Microsoft has declared it dead, but it is still active. You can still build a lot of desktop application with it. Most companies are still using it as a legacy system. I wouldn't spend more time on that. You can do more research on it, but it's not really required out there these days. I'll just put it at that. Now, going to the web forms. Web forms is pretty much outdated, but there are still more companies that are using it as a legacy system. So it is the first or one of the early web application frameworks or architecture by .NET. So this is a very heavyweight code behind pattern of writing application, and it's pretty much slow compared to what we have these days. So web form is one of those early web application, architecture by .NET framework, Microsoft technology to be precise. So web services in itself is the first attempt to create by .NET to create a web service where you can actually have multiple applications talking together. But this ended up becoming something that is restricted to the Windows operating system. You cannot use it in any other OS outside of Windows. So pretty much most of these things here in .NET are restricted to Windows environment. But as time proceeds, .NET came up with ASP.NET MVC, which is a separation of concern, pretty much, to solve the problem of the code behind in web forms. So ASP.NET MVC separates the model from the view from the controller, and this becomes pretty much lightweight. It makes application faster, simply because you have the model in a separated folder or tier in the application. You have the view, which is the CSHTML. This is a part where you can write your HTML code, CSS, and JavaScript to handle the behavioral aspect of the front end. And the controller is where you write the business logics. What should happen when a specific button has been triggered by the user in the front end. There's a lot to ASP.NET MVC, but I'll just keep it at that just to go through this roadmap. Now, moving forward to the Web API. Web API is the first RESTful service. I think that is the upgraded aspect of the web service that .NET was trying to create here. So Web API came to solve that problem. What Web API does is basically a fully back-end development architectural pattern. So we build a full functional backend and we can consume it with any front end. For example, you can build an application that has both the web version and the mobile version. Now, if you log into your application on the web version and you log in with your username, you get the same data that you will also get when you log in using your mobile application. So that means that both the user interface in the web application and user interface in the mobile application are talking to the same backend. That is what Web API does. So you have one backend that is being consumed by multiple front end, and it can also talk to other services as well. But there's still a problem here. All of these are still restricted to the .NET framework. So what do you have to the Microsoft Windows environment. So what if you are trying to use any other operation system? That means your application cannot run on it, right? That's what the .NET Core framework solves. So it becomes it's an upgraded version of .NET framework, which is an open source, and it also works with multiple platforms as well. So it's not only restricted to Windows. You can build application on it, and it can run on any platform as well. So that's just the difference between the .NET and the .NET Core framework. The .NET Core framework is, the upgraded version of .NET framework, which is more open source, and it allows the .NET applications to run on multiple platforms as well. So on this right side here, this is a general practice in software engineering. You also want to know about authentication. This is a process where you have to authenticate the users that are logging into your application. There is a way you have to ensure that users' data are safe, right? Anybody can just log into the application. So there are different ways you can use authentication. You can use the basic authentication depending on the critical security level of the application you are building. You can use JWT token authentication. The token authentication has to work with the OAuth frameworks. I wouldn't go much on this, but just know that authentication is something you have to focus on. We're doing a course on that. Then authorization is to assign tasks to every user. So when you log into the application, what are you authorized to do? As an admin, definitely you have to see, you have to have more access to functionalities and, have probably different views. You can do what most users can do. And as regular users, you are restricted to only your own profile. So that's what authorization do. It separates the roles of all the users in the application. Logging is a very important aspect. So logging, what we do in logging is to ensure that you log all the activities in the application. So by logging all the activities in the application, you ensure that if anything happens while your code is running or in production or the code crash, you can easily trace the problem. It makes it easy for you to debug what happened because the log information will tell you where things has gone wrong instead of you flying blind and trying to figure out what happened to your code. Right. Session is a very important aspect as well. Session is just to keep track of activities of all users. So you know what users did what at so time. And if your application is a very secured one, you are trying to keep it secure in a way that if it's been inactive for a specific period of time, it should just log the user out or kill the session. Session is a very important aspect to know as well when you're building fully functional projects. I'll also be making a course on that. Caching, I recently made a course on caching and cache invalidation. This is a process of optimizing your application. So you want to ensure that when the application is running back and forth to fetch data from the back end to the front end, that takes time. That also consumes memory space. So the fastest way we can do this, the best way approach to this is to ensure that once we go to the back end to fetch the data, we keep it in temporary storage memory. So when user keeps calling the same data, the request doesn't have to travel all the way back to the back end and fetch data. It will be readily available in the temporary storage in the front end. Because sometimes when request is going to the back end to fetch data from database, it might pass through a whole lot of services. And this makes applications slow sometimes. So it's pretty much important for a, full-time developer to understand how to implement caching as well when building fully functional applications. Now, one other thing is resiliency. Resiliency is basically a fallback pattern. What should happen when your application crash at runtime? What do you have a plan B when you have an application that is floated live and users are using it and some huge error or fatal error occurs while the application is running? Is it just going to crash? Because when you have an application that is running and then users are using it and it automatically crash on the users, trust me, no user will want to use the application again because the issue of integrity and safety is out of there. Your application can crash anytime, then nobody will want to transact or whatever on your application anymore. So resiliency is a fallback pattern. Like if the worst occurs, do you have a backup system that the request can fall to? For example, in caching,
if you are using a caching memory, right? And what if the caching server failed? Probably like Redis. What if it fails? Do you have something it will fall back on? Maybe fetch it from the local repository in the production environment or something. So resiliency will take care of that. So resilience is basically like if something was happen, you have to fall. There's something to fall back on, or something that can handle that fatal error. That's pretty much about resiliency. So let's go into design pattern. As a full stack developer or as a full-time programmer, you have to understand things about design pattern. There's a lot of design patterns out there, but I would just advise you focus on the widely used one like singleton or decorative pattern. This is pretty much things you have to understand and analyze before you start jumping into code, right? You want to understand what you're trying to design, what pattern of approach you're going to use to design what you're trying to design or what you're trying to build. So design pattern is pretty much very important to know. So testing is also very important. You have to test your applications. You have to test your code before it deploys to production environment. So unit testing is very important. You should know how to unit test your code. And also integration testing is also important as usual. So there are several types of testing as well, but I would say just focus on unit testing and integration testing. As you proceed in your career, you will see why you need to know more about other type of testing as well. ORM, this is Object Relational Mapping. So this is basically a database connectivity framework. Your application will be connecting to the database. And when you are connecting to the database, there has to be some channel that you have to pass through, or some kind of funnel that, like a pipeline that passes data back and forth from database to your application. So ADO.NET is the traditional one we used to use, which is more like a direct manual way of writing code to request and, perform database activities such as create, receive, retrieve, update, and delete. So ADO.NET is pretty much important to know, but with the help of Entity Framework and other database connectivity framework, it has kind of, made ADO.NET redundant, but it's still there. Like there's DEPA framework also, but ADO.NET is a basic requirement to know when it comes to database connectivity in .NET framework. But Entity Framework is more automated, whereby you don't have to do much, just know how it works. So you can use the code first approach in Entity Framework, or you can use the database first approach. So these are also very important aspects to know when you're working with .NET framework. So with all of this now, like I said, it's not an overnight process, and it's not something you can, rush out to understand. But if you take your time to know how all of this works, not necessarily everything, but this will get you going. And as time goes on, experience will teach you the rest. That is what matters the most. You just need a spark of the basic understanding of how these things works. And as you proceed and you work on different projects, experience will, give you the rest of the learnings you need to understand. And that's how .NET framework works and the new .NET Core framework works. If you think I'm missing anything, put a comment down, or if you want me to do a course on any of these topics that I've raised here, I'll be glad to grant your request and do the course as well. But I'm currently working on these courses here. I've done caching recently. I'll probably work on session or login next, and we can go from there.
Of course, this is not an overnight work. It takes a while to get used to the whole thing, but with the roadmap I've laid out here, if you follow it structure by structure, break it down and, start taking it one after the other. Don't jump into the next topic until you fully understand how one works, because this whole structure here is that when you understand number one, you will be able to use number two. When you understand structure number two, you'll be able to use number three, and it keeps going like that. That's the way I've laid out the structure. But the moment you jump it or try to take it from the top or the hardest part, you start flying blind as a beginner. But if you are the type that has, had a lot of experience from other languages, the only thing you have to do when you migrate to C# is just to understand the syntax, and you can go from there. Don't forget to like, share, and subscribe to my channel for more videos.